Hello everyone, we're Group 23 and we propose the Aquarium Management and Monitoring System. Before we start, let us introduce ourselves.
My name is Benji, and I'm a fourth-year CPEC student.
My name is Jaspreet and I'm a third-year CPEC student. For our project, we wish to create a small-scale embedded system which can simulate a working aquarium. It will have all the basic necessary functions required in an aquarium, such as monitoring environments and protecting species from theft.
We are expecting our system to work under three modes. In the environment mode, we will be ensuring the water is within the optimal quality levels. We will be using sensors to check the pH, temperature, and the water level. For the security mode, we will be protecting the fish by keeping thieves or other pets away. If the fish tank is moved, the buzzer will go off, alerting the owner. And finally, for the feeding mode, it will allow the fish to be fed without the owner's presence. A motor will be activated at regular intervals for feeding the fish.
The main role of the microcontroller can be divided into three main aspects. The first aspect is the microcontroller being a sort of a management system for all the sensors. There will also be an internal timer to calculate the exact time to feed the fish. Since when the time to feed the fish is suitable, the motor is expected to turn, but in order for the motor to turn, we require a PWM signal. So a timer will be used for producing PWM signals for the motor. We're also going to use a microcontroller for IO notifications of unsuitable working conditions or theft. So a buzzer will be used as an alarm for theft, and RGB LED will be used for notifications for unsuitable working conditions.
For our proposed sensors, we will have a temperature sensor to sense the water temperature, and a pH sensor to sense the water pH, and a capacitor proximity sensor for checking the water levels. And finally, an HMC digital compass, which will check the orientation for the security mode. For the sensor placement and layout, we are planning to have the pH sensor and the temperature sensor inside the water, actively monitoring the water quality. We will place the capacitor proximity sensor right at the limit, so it will alert us when the water is below the limit. And we will have HMC digital compass for calculating the orientation properly at the bottom of the tank. Add a servo motor at the top of the tank for releasing the food.
So we use the built-in LED and the microcontroller to show us if the environmental indicators are in range. So the default setting is that the LED is off and every environmental indicator is in suitable levels. The LED will turn red if the pH level is outside the suitable range. It will turn green if the temperature is outside the suitable range, and it will turn blue if the water levels have gone under the specified limit.
For our additional devices, we will have the servo motor for the feeding. It will go off when it's time to feed the fish. We will also have an LCD screen for displaying the user input and the sensor outputs. And we will have external buttons. We will need 4 buttons in total.
The LCD will be used as a visual interface for users to set their parameters and specify the suitable ranges. Users can choose to have a suitable pH range, a suitable temperature range, and also they can choose their feeding time.
This is the end of our presentation. Thank you for watching.